Arctic and the Antarctic play the role of kind of like an air conditioner for the Earth systems. They're cold, they have a lot of ice, they reflect a lot of the solar energy, so they stay colder than they otherwise would. They're more sensitive to climate change, and therefore they're the regions that we see the biggest effects of climate change so far and the biggest effects of warming. They're kind of the canary in a coal mine of global warming.
This year's Arctic sea ice minimum is in about the top 10 of the lowest that we've seen in the last 3.5 decades. As the global temperature has increased, the temperatures in the Arctic, especially in the past decade, have increased by about 2 to 3 times the global average. And so what's happening is temperatures increase, ice melts.
Well, this year in the Antarctic we've seen a pretty spectacular maximum extent. The Antarctic sea ice has expanded beyond anything we'd seen before and set a new record. The increase that we're seeing in the Antarctic extent is a little bit of a mystery. We're seeing overall temperatures warming around the globe, so you would expect to see ice loss. Some people have looked at the Antarctic increasing trend and used that to suggest that global warming isn't happening, or that the increase in the Antarctic is offsetting the decrease in the Arctic. And that's simply not true. If you look at just simply the magnitudes of the changes we're seeing, in the wintertime the Arctic is decreasing about twice as fast as what the Antarctic is increasing. It's important to look at the relationship between the Arctic and the Antarctic, because studying those gives us an indication of what changes we're going to see around the rest of the globe in the future. In this animation, we're taking Arctic sea ice into the third dimension. Here, we're looking at the ice age, which is an indicator of thickness. Generally, older ice is thicker ice. And so what you see in this animation is, first of all, the ice pulsing out and in with the seasons. In winter, the ice grows out and expands outward. In summer, it contracts inward as it melts. In addition, you see the whiter ice, which is the older ice, moving around the Arctic, being pushed around by winds and currents that move the ice. And what you can see is, over the years, the ice pulses around and it moves around towards the top along the coast of Greenland. You see that the older ice eventually moves out of the Arctic and into the North Atlantic, where it melts. But the ice gets replenished within the Arctic because some of the ice survives each summer and grows older. And particularly in a region north of Alaska called the Beaufort Sea, where the ice spins around in a clockwise direction called the Beaufort Gyre. And that ice can keep spinning around, oftentimes for several years, and gradually getting older and thus getting thicker. Eventually, the ice will spin out of that gyre and go out through Fram Strait. But in the past, what has happened, we've always had enough ice growth and ice aging, enough ice surviving the summers to replenish the older ice that's lost. But in recent years, we've seen less replenishment. There's been more melt during the summer, and so the ice that goes out through Fram Strait has not been compensated by the ice growth. In addition, especially in recent years, we've seen some pretty remarkable things in the Beaufort Sea, where that area that used to be a nursery for the development of the older ice, allow the young ice to age and mature. What we've seen instead is the ice is now more broken up, more scattered, and that's allowing the older ice to melt within the Beaufort Sea. So we're seeing the Beaufort Sea go from a nursery to a graveyard for older ice. And as we get towards the more recent years, much of that oldest ice, the ice that's older than 5 years old and the bright white, has almost virtually disappeared from the Arctic Ocean, and the Arctic is now dominated by younger and thinner ice.
On March 17th, the Arctic region reached a milestone, the second lowest sea ice maximum extent since satellite measurements began. The 4 lowest maximum Arctic extents on record have been in the last 4 years, according to analysis from NASA and the National Snow and Ice Data Center. This year's maximum extent reached 5.59 million square miles. But what does that really mean? How and why do we track sea ice?
We've got a good record of extents since the late 1970s. So by now, the record of the Arctic ice is clearly one of a decreasing ice cover.
To answer some of my questions, I talked with Dr. Claire Parkinson, who has been studying sea ice from space for the past 4 decades.
I got a job at NASA's Goddard Space Flight Center in July of 1978, and I've been here ever since, and I've had the phenomenal opportunity of getting to start when the satellite data was still fairly new, and when at Goddard people were trying to figure out how to use the satellite data to reveal information about the Earth. After several years, when we started getting a longer record, then our attention got changed into, well, what kinds of trends are we seeing in sea ice? We've maintained this record of sea ice, and we recognize now that it's very important for climate change because sea ice is one of the variables in the Earth system that has been changing the most dramatically, especially in the Arctic.
But sea ice doesn't just react to warming global temperatures. It can actually accelerate the temperature increases.
Now, the less sea ice coverage feeds back into the warming, because if you've got less sea ice cover, that means less of the sun's radiation that comes down to the surface will get reflected back.
Sea ice fluctuates with the seasons, growing during the cold, dark winters until reaching an annual maximum extent in February or March in the Arctic, and then shrinking through the summer until reaching a minimum in September.
In the Arctic case, in late summer it extends over about 5 million square kilometers. In late winter, it extends way further, over about 15 million square kilometers, which is about 1.5 times the area of Canada.
So studying sea ice includes tracking how it changes seasonally. Rather than just looking at the annual summer minimum, scientists track how the ice changes throughout the year to get a fuller picture of change.